So far all of my milling operations have been carried out with the aluminium block clamped onto the table in its final orientation, and by that I mean the top of the yoke, as it will be, has been facing upwards. To drill and bore the fork leg clamp holes, I'm actually going to position the block the other way around, so the top will be clamped against the table. Before I do so, I do need to skim off the top to ensure that it is parallel to the bottom surface. And interesting enough, before I do so, I did do some quick measurements using a micrometer, and we can see actually it's pretty damn good as stock material. So 4 measurements, one in each corner of the central part, are varying from 51.13 millimeters to 51.17 millimeters. So a variation of 0.04 mil over that area. Just out of interest, a quick review of the results of skimming off that surface. As we can see, the measurements, we are ranging from 50.82 to 50.86, so the variation is still 0.04 millimeters. Given the quality of the mill and its age, I think that's pretty damn good, and of course it doesn't account for any variations in the bottom surface, which we'll deal with later on because that will also be skimmed. To drill and then bore the holes to the clamp legs, I've now got the block face down, so the top surface of the yoke is now facing down on the table. These cuts are going to be quite critical. If I get these wrong, then the yoke is not going to fit on the bike, so it's very important I get this right. The first thing I need to do is ensure that the workpiece is clamped parallel to the x-axis of the table. As we can see, I've got a dial gauge set up against the front surface of the yoke. What I'll now do is just run the table backwards and forwards, and we'll see what variation we're getting. This should be pretty much spot on as I've already set it up. Zero on the gauge. So as we can see, the variation is incredibly small at the moment across the full length of the yoke. We have 0.01 millimeters. What I need to do now is find my reference point, so I'll use the wiggler to get the right hand side and the front side, or the front face. Of course, because the block is upside down, my reference has now moved from the left side to the right side, so it's this corner here I'm interested in. Once I've found the corner and can position the quill directly above it with 0 on the X and 0 on the Y in the DRO, it's going to be simply a case of offsetting the table to find the centre of this hole and the centre of the other hole. Once I found the centre, I'll drill it out to the largest drill size I have, which is 20 millimeters, and from that point I'll then move over to boring the hole out to the required size. This stuff is coming in as swarf. It's very, very sharp. This is the largest drill I now have. This is 20 mil. So from beyond here we'll have to start boring. Okay, I'll now go and drill the hole on the other side to the same size. I have now past the point of no return, almost, by drilling those 2 holes. If I've got my measurements wrong or I've got my setup wrong, the yoke will not fit the bike. I've still got a bit of leeway. The drill itself, or the drill chuck in the milling machine, will have a bit of run out, so the drill is not particularly accurate. The accuracy will come when I bore the holes using a boring head. So even if those holes were half a mil or 1 mil too far apart or too close to each other, now would be the time when I start the boring to compensate for that. But I'm confident I've got it right, so we'll push on. A word or two about boring heads. As with a lot of my tools, this is a budget item, so it's not going to be the tool room quality you might see on a lot of other people's videos. But it's good enough, and it will certainly get me through what I need to do here. These boring heads generally come with sets of boring tools. Mine was no exception. There are some interesting videos on YouTube about these things. People get very mixed results with them, in fact normally very poor results. From what I've seen and from people that know a hell of a lot more about engineering than I do, one of the main concerns is the geometry, how the head itself is actually shaped. So having looked at a few of those videos, I've actually reground the head on this one quite significantly to try and bring the cutting point onto centre, and also to give some rake to the cutting head. So that profile there is quite different from how it came. I have done some test cuts with it and the results were quite positive, so fingers crossed. I've got quite a lot to play with here, so I can make a few mistakes on the way before I start to get to the final dimensions. Okay, so I've now got the boring head set up in the mill. I've had to drop the head down, and therefore I've had to refine that reference corner. And right now the centre of the quill is again right above that corner, so right on the reference point. I'll now move the table to get the boring head and the boring cutter over the centre of the hole, and we'll go from there. So this is currently a 20mm diameter hole. The diameter required is 34.7 because the forks are slightly undersized for a 35mm and nominal 35mm. So we've got quite a lot of material to come off, so we've got to go from a radius of 10 out to a radius of 17.35. So nearly 7.5mm needs to come off that. It's going to take quite a while. I'll get a first cut or two underway in the video, and then we'll come back towards the end. For those not familiar with the boring head, it's set up in such a way that the position of the cutting bar or the boring bar itself can be moved in or outwards on the radius via a very fine screw thread here. You won't be able to see it on the camera, but the divisions on that are 0.02mm on the diameter, so each little graduation is 0.01mm on the radius. I'll just get it cutting first and we'll go from there. Just a quick progress stop part way through. I've swapped out the boring bar for a slightly more substantial one. I was getting a fair bit of spring in the previous one, so hopefully a little bit less with this one. The little graduated dial, although it states 0.02mm on the diameter, it is in fact on the radius. So we'll just catch a couple of passes now. You can hear as we're coming back up that the cutter is cutting again, which is the indication of the spring movement in the bar. But it is giving a beautiful finish. These boring bars are actually carbide tipped, although one of the other general concerns about them is the quality of the carbide tip itself, but it's doing quite well at this point. Okay, we'll come back towards the end. So that is 33.4mm. So half a turn on our little calibrated wheel here gives 1mm change in radius. We are currently 33.4 and I'm looking for 34.7, so we'll do another half turn to bring us up to 34.4, and then we'll start putting some fine cuts on to finish off. Measuring internal diameters is a bit of a chore. It's not that easy to do. The pros that are much more practiced than I am would use a little telescopic gauge and then put that against a micrometer. There's an art to doing that, and something I don't possess. What I generally tend to do is what I've done here is turn a little test piece with a number of diameters. I don't know how clear it's going to be, but there's 3 diameters on the stub there. The innermost one, the left hand one, is 34.7 millimeters, which is our target. Just to the right of that is 34.6, and just to the right of that, or the first diameter, is 34.5. So it's a no-go, it's a go, no-go gauge, and hopefully we'll get it to go in each diameter at a time. Okay, so interestingly enough, my go-no gauge has gone onto the first diameter, which says that we are 34.5 millimeters. It's snug in there, it doesn't want to come out. So really am into polishing. I might run that up and down a couple more times before putting any more cut on. So it's not dropping onto the 34.6. So theoretically I've got 0.2 millimeters to come off that diameter. Using carbide for basically polishing cuts is not the best. So that's dropping onto 34.6 diameter, but not the 34.7. Yeah, definitely not dropping down. One more very small cut. Right, he drops through. That means we are on or over size. We'll stick with that and move on to the other hole. To finish this video, both holes have now been bored to the right size. I'm very pleased that it does fit on the bike, because that means not only have I got the diameter of the respective clamp holes correct, but I've also got the spacing between them, the 180 millimeters. So that was the first of the 2 critical dimensions. In the next video we'll move on to the same exercise of drilling and boring, but this time for the stem. That will be the other critical dimension, making sure it's smack between the 2, and also the respective offset back from the fork leg centres, which according to my little play around with Pythagoras should be 65 millimeters.